Okay guys, this is lecture 11 now, and this will be about universal array functions. So let's start off by importing NumPy as NP, Alt Enter, and let's go ahead and make an array to start off with. We'll just call 11 points and show it so we can have 0 through 10 in our array. So universal functions are basic functions that you can apply to every value in an array. So for instance, we can take square roots by calling np.sqrt, and we can call it in our array, and now we've taken the square root of every value in the array. So if we look at 4, we should have a 2 there. Yep. And 9 gives you a 3. Cool. So what other things can we do? We could possibly take the exponential of every value in the array. So basically have e to the power of the number, the value point in that array. So if we run that, that's what we get. First value makes sense, right? Because e to the power of 0 is just 1. So that worked out. There are also binary functions. Those will require 2 arrays because of the term binary. That makes sense. So how about, in order to see that, we'll create a random array. In order to do that, we'll call NumPy using np. Then we'll call random from the NumPy library. And then we'll call a random normal distribution, and we'll have it be 10. And let's go ahead and see that array. And if you don't quite get what we just did here, we'll be going over it a lot more throughout the course, so don't worry about that too much. Let's go ahead and Alt Enter. Cool. So now we have our array that's a normal distribution of some random numbers. Let's create another one. np.random.randn of 10. And let's go ahead and see that as well. Cool. There's our other guy. So in order to do some binary functions, all that means is functions that use 2 arrays. So for instance, adding arrays. So this will add every value of A to every value of B. So this first value of A to this first value of B. Let's go ahead and see how that looks. So we have negative 0.3 blah 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 plus 0.11 gets you negative 0.23, etc., etc. Other things we can do is find the max or min between 2 arrays. So in order to do that, we can say np.maximum, call the 2 arrays, and this will find the maximum between the 2 array values. So to see what I'm talking about here, if we look at our original arrays, A and B, it will compare the values at each index. So the first one was negative 0.35 in array A and 0.11 in array B. So it's going to compare those and see which one was the max, and then set that as the value for that array you just called. And it's going to do that for each of the values comparing A and B. And you can also check for minimums just by calling np.minimum. So for a full extensive list of all the universal functions, you can check out the documentation. So I'm just going to edit, copy, and edit, paste the website here. And again, like always, you can just click on the links to see the IPython notebooks from GitHub. If we want to see this website, a little trick we can do is import web browser and then call web browser to open that website link. Let's see if that works. Yep, looks like it did. So here are all the available math operations, these ufuncs, universal functions. So you can add, subtract, multiply, divide, take the log of the sum of the exponents, find remainders, find signs. There's a whole bunch of stuff you can do. Take square roots, get the squares, and we'll be using this as we need them. And you can also do trigonometric functions, get the sines of the values, the cosines, the arctans, etc., the hyperbolics, and then there's comparison functions as well, which we'll look into later. So you can go ahead and check out the documentation on these universal functions in case you're looking for extra ones or more info. Alright, so that'll be the end of lecture 11, and I'll see you at the next one.